Hey guys, it's me again. All right, here we go. I know this stuff is weird. I get it. I really do get it. Let's go ahead and get started. 11.3, multiplying radicals. Okay, hopefully the stuff that y'all did yesterday was beneficial and that you understood it, because I've yet to hear from anyone, and it seems like, well, as of making of this video, and I'm guessing that y'all understood it probably a little bit better than the first one. Okay, you need to have a really good understanding of 11.2 simplifying radicals because of what we're doing today, and then the next lesson, which is dividing. Today isn't going to be too bad. I don't even have that many notes. I just have a couple things, and then it's examples. And it's really, I really think that the first section that we did, expressing roots, I really think that's the hardest, and that's my opinion, okay? Some of you may think the opposite, like Monday, yeah, I think it was Monday. The first one was the easier, and then these are too confusing. I don't know. Everyone's built differently. So if you have questions, guys, seriously, after watching the video and everything, contact me. Don't just say, I don't understand this. No, I need specifics, because otherwise I'll refer back to the video. So you need to say, Mrs. Rogers, I don't understand this particular problem, or something like that. And then I can help. But no more broad, I need help, or I don't understand. Give me specifics, and then I can go with that. All right? All right. So the steps in multiplying radicals. Write the radicand. Remember, that's the number that's inside the little funny check thing. Okay? That's the one inside the radical. Write the radicand as the product. Remember, product is multiplying, have their little dot there, of its prime factors. Okay, it's going to be very similar to what we did in the last lesson. 2, you're going to simplify the root of each perfect power. And I know a lot of this doesn't make sense, but you know I'm going to give you some really good examples, okay? And then 3, simplify the resulting expression. Okay? All right, so we're going to go ahead and jump in to examples, because that's the best way that y'all learn, to be honest. So examples, page 444. If you need to pause the video and get your book out, go right ahead, because we're going to jump right in. I'm waiting for UPS to deliver something, so I may have to pause the video. Hopefully not. Okay, so let's look at number 1. Okay, it just says to simplify. Again, you notice that it's written a little bit differently. Okay, so let's get going. So the square root of 5 times the square root of 3. Okay, now watch this. Watch this. Notice that 5 is prime. Notice that 3 is prime. So, like in the last lesson, can we simplify these? Can we do a factor tree and take a bunch of stuff out and everything? No, these are already prime. So, this is hard now. The square root of 5 times the square root of 3 is the square root of 15. That's tough, isn't it? I know. It took me couple years to wrap my head around that. All right, so If the number inside the radicand is prime and both of them are prime, you just multiply. Call it good. Isn't that nice? Now, that's number one. Do you think the rest of them are going to be that easy? No. First one's always the easiest. Okay, so, but they're still not bad. All right, so let's go to number 3. Let's go to number 3. It's going to get a little bit, a little bit different. So this one is square root of 8 times square root of 3. Okay, so we know that 3 is prime. Okay, but 8, it is not prime. So we're going to have to do a factor tree on just 8. Oh, it's a good song playing in the background. Okay, so I don't have to play music while I'm teaching. Okay, so we're doing the factor tree of 8 because 8 is not able to be 8 is not prime, so it needs to be simplified. So let's do our factor tree. 4 times 2, 2 is prime, so we circle it. 2 times 2, and those are both prime. Watch what I do here. Just like the last lesson, I'm going to write out my prime factors while crossing out and multiplying. See my dots? Here's the thing. See this 3? I'm going to take that 3 that was prime and I'm going to tag it onto the end here times 3. Okay? See how I did that? If you need to rewind the video and look at that again, this one is not prime, so I do the factor tree and write out my prime factors minus that 3. That 3 is prime, so I take it and just tag it on there at the end. All right? Now, do I do that 8? No. So what is the root for both of these? This is just like your last lesson. The root is 2 because you notice there's nothing here. So the root is 2. So just like your last lesson, I'm going to go over here and I'm going to circle my group of 2. Groups of 2. Where did I tell you that went? On the outside. That's right, on the outside. I know some of you hate my arrows, but I don't know what else to do. And then I have this 2 and 3 left over. So they go in here. Remember that? 2 times 3. So the 2 left over go in here. That one group goes right here on the outside. Okay? So you may want to because if you look at this now with all my arrows, it's kind of messy. So you may need to rewind and go back over it step by step. So what's 2 times 3? It is 6. And there's my answer. Okay? So again, this is prime, so we need to mess with it. This was not prime, factor tree, wrote out my factors, tagged on that 3. They both have a root of 2, and no, they will not have like a 2 and a 3 here. So I know some of you are probably wanting to raise your hand and ask that. No, they're always going to have the same root, so don't worry about that. You write down your root. You're looking for groups of 2. Not 2 the number, but 2 of the same thing. That goes on the outside, and only 1 goes on the outside. You don't need to put 2 back down there. Your leftovers go on the inside. You go ahead and multiply them. Okay? All right, let's do another. Now, I was told by my family I am too loud, so y'all just going to have to turn down your volume. That's just too bad. Okay, 5. Number 5 is square root of 12 times square root of 5. Okay, now notice this one is prime, So we do not need to do any factor tree with that. This one is not prime, so we're going to need to do a factor tree. We have 6 times 2, and 2 is prime. We have 3 times 2 here, and those are prime. So I'll go down here, and really I'm not even going to write that 12. You can if you want to, but I'm just going to list 2 times 2 times 3, and I'm bringing over. Now remember, this 12 needs to be, here goes my arrows, it needs to be done as factor tree. What do I do with this 5? I'm going to take this 5 and I'm going to bring it on over here and tag it on the end, just like that. So I wrote down all my factors, made sure I wrote them least to greatest, and I'm going to take that prime number and just add it right there on the end. What is my root? See, y'all can be doing these problems while I do this, your work. You can pause it and do some, that sort of thing to help you remember to look for the root. There's nothing here, so that means your root is 2. So I'm looking for my groups of 2, not just the number 2, but, a pair, I should say. Groups of 2. And here's one right here. That goes to the outside, 1, 2. And then these leftovers go to the inside. And make sure that you remember to multiply. So 3 times 5 is 15. So your answer is 2 times square root of 15. See that? That's not too bad, is it? All right, let's do another. 9. This is a little bit hairier. Square root of 28 times square root of 35. Okay, square root of 28 times square root of 35. All right, guys, neither one of these are prime. See, now it's getting kind of crazy. All right, so these two, you're gonna have to do your factor tree for both. All right, sorry about that. 7 times 4, and you can use any numbers right here as long as they work. And then 2 times 2. Circle your prime numbers. Here, 5 times 7. Both of these are prime, so I'm going to circle them. All right, now watch this. This is why up here I quit doing that, where I put 12 and the colon and everything, because check this out. Now, we're not going to just list 28 prime and 35 prime numbers. We're going to combine them all together. I'm going to go least to greatest. Least to greatest. Least to greatest. All right. So 2 times 2 times 5. See, I'm combining them all together. Whoops. Times 7 times 7. Did I have any prime here? Nope, so I don't have to tag anything down here at the end. So all I did was list my prime factors all together. All right, all together. And from least to greatest. What is my root? Well, by now you should know there's nothing there. I'm not even going to write it in red. It's 2. And by now you know I don't need to write groups of 2. So I'm going to circle my groups of 2, and I have a 2 and a 7. Where do those go? I'm not going to draw any more arrows. Where did the 2 and the 7 go? They go on the outside, boys and girls. A 2 and 1 2 and 1 7. Make sure you put that multiplication dot there. Then you have your radical sign, and that leftover 5, that's the only one left over. It goes smack dab in the middle. 2 times 7, what is that, boys and girls? That's right, it is 14 times square root of 5. I need to start making my videos during the day. I have way more energy. Mm-mm-mm. Okay, there we go. I think I'm a better teacher during the day. Alrighty, let's go to 13. Ooh, 13. All right. What on earth? Oh, yeah. Yeah, we only have a couple more to go. Okay, now 13 looks weird. Looks weird in the book, too. All right, here we go. Square root of 3 times square root of 2 minus 1. By the way, I have to pause for a minute. So Allie is doing pre-cal, honors pre-cal. And she was showing me one of her problems. Guess what? It's algebra. Sure is. It was FOIL. Remember FOIL? And distributive property and stuff like that. That's right. You have to know this stuff in these radicals and things for Algebra 2, geometry, and even pre-cal. Okay? Owen's sister will tell you that. You have to know this stuff here. And the stuff you just had, tests and stuff on with the FOIL and all that good stuff. You got to know that for all your next future math classes. So y'all better know this stuff. Okay, so what does this look like? Speaking of distributive property, that's right. It's the distributive property. So we're going to take this square root 3 and we're going to multiply it by everything in these parentheses or this parenthesis here. So square root of 3 times square root of 2 and the square root of 3 times negative 1. Is 3 prime? Yep. Is 2 prime? Yep. So what did we do back here in the first example? We just multiplied. So square root of 3 times square root of 6, square root of 3 times square root of 2 is square root of 6. And square root of 3 times negative 1, it's exactly what you're thinking. Negative square root of 3. This cannot be simplified anymore because, like the last class, last lesson, you would do like, this is prime, right? This is prime. This isn't prime, but if I did a factor tree over here, it'd just be 2 times 3. And there's root of 2, there's no pairs. So it is already, oops. That's your answer. Okay, you simplify if possible. If you can continue simplifying that with the factor trees and all that good stuff, you know what I'm talking about? Like this right here. If you can do this, then you need to continue doing it. Okay, after you do the distributive property, you need to keep on doing that. All right, but if not, then you're good to go. You're done. All right, so for example, let's look at 15. Square root of 7 times square root of 21 plus square root of 2. Okay, this is the distributive property. So this is going to be times that, and this is going to be times that. This number on the outside parentheses times everything on the inside. All right? So here's what's really weird. Notice that this is prime. Notice that this is prime. Notice that this is not. Okay? So I want you to watch what I do. This right here is not prime. In fact, I'm going to write not prime. So I'm going to over here do a factor tree of 21. What do we get? 3 times 7. So remember what we did earlier. This one right here. We're multiplying, right? Aren't we multiplying this times this? So we're still multiplying. This is prime. So remember, I took the prime one and tagged it on the end here after I did the factor tree of 12. That's what we're doing here. We're kind of like just looking at these two. All right. So this times this. So I'm going to write my prime factors from the 21, but I'm going to tag on this 7. What is my root? The root is 2. So I'm going to circle my group of 2. Where does the group of 2 go? On the outside. The leftover goes on the inside. So this is the answer for this. Okay? Now, this is prime and this is prime. So the square root of 7 times square root of 2 is square root of 14. However, could this be simplified more? Can it? No, it can't. That would just be 7 times 2. And there's no pairs there. See, let me show y'all real quick. 7 times 2. Is there, I mean, we're multiplying. The root of 2, is there any pair here? No. So you can't do it. So guess what? This is your answer. Now you may want to go back and review that problem right there, because that was kind of weird. Okay? So we multiplied this. Y'all, you could have, being that this is prime, y'all could have just multiplied those and then did a factor tree. Just like you did here. It's entirely up to you. But this was a little bit easier. That's it. This is a prime number. And I think for the most part, they all are. All right. Let me show you 17. 2, 3, 4, 5, 6, 7, 8. Yeah. We're going to do a couple more. Okay, so it's, oh, look, there's a root of 3. So cube root of 40 times the cube root of 54. All right, ladies and gentlemen, neither one of those are prime, so we've got to do our factor tree. Ooh, this is a good song. I got some good music playing. All right, 54. Okay, so which two numbers, blah, 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 blah. All right, so let's do 20 times 2. 2 is prime. And then we can do 2 times 10. 2 is prime. And then 2 times 5. And those are prime. And then 54, I can do 9 times 6. 3 times 3, and those are prime. And then 2 times 3, and those are prime. All right, now remember, we're not looking for greatest common factor or anything, so remember what I said, when you're doing 2 factor trees, you combine all of the prime factors in least to greatest. So I got 2 times 2 times 2 times 2 times 3 times 3 times 3, and then times 5. Now you see why I cross all those circles out. You want to make sure you get them all. Okay? You don't want to leave any out. Your root is 3. See that 3 right there? Yeah, man, that 3 right there. So what are we looking for? I'm going to write it. Groups of 3. All right, so I have a group of 3 here and a group of 3 here. Okay, these are my leftovers. So I'm putting a 1, 2, guys, only 1, 2 here and 1, 3 out of that group there. Times square root of, and the leftovers go in the check thing, the radical sign. So 2 times 5, don't forget that multiplication thing there. And also root 3, so the little 3 needs to go there. 2 times 3 is 6. Put your little root 3 there. 2 times 5 is 10. And there's your answer. Now, I may be talking fast, so if you want to go back and review that, you certainly can. All right, guys, we're on the last example. Oh, I don't like this song. Okay, 25. All right. Ooh. Yeah, this is ugly. Do I want to do that? Yeah, I gotta teach all the variables. Dang it. Okay, here we go. I gotta do the variables, guys. I really do. Or do I? Oh, just a second. Just a second. I'm trying to decide how badly do I need to do the variables. You know I don't want to do it because it's hard. I mean, it's not that hard. Let me see this real quick. It's not that bad. All right, I'm going to blow it off. Call it distance learning, okay? If you can do the radicals the way they are, I'm okay with it. I'm okay with it. All right? I'm probably going to regret this. And if I start going in there and I start looking in the state requirements and I see y'all got to know variables, which I really don't think you do right now. But I don't want to mess y'all up either. You know, I don't want to teach you something you don't, you know, and confuse you. I want you to know this, but I also want to make sure you get the information on variables. It's not that bad. I'm going to skip it right now, okay? I'm just going to skip it right now. If later on I need to come back and revisit this and teach it to y'all, because I got to think this through a little bit, then I'll come back. Okay, I'll definitely come back. It's not bad, but let's just figure out what y'all are doing right now. Because I think if you go into geometry and algebra 2, at least understanding this right here, the letters, you'll be older and it'll be even a little bit easier. So let's do that. 2 through, let's see, numbers 2 through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, 2 through 20 even. That's 10 problems. All right, guys? All right, so contact me if you have any questions. Your IXL, I'm sorry I'm yelling. It's due Monday, and you have a quiz Monday on all this stuff, okay? You have a quiz on all this stuff. This is due Thursday, right? Yeah, let's do Thursday. All right. If you have any questions or need help, let me know. Bye.